Alright guys, we're going to be looking at section 6.3 today. This section is very similar to section 2. So basically what we're going to be doing is we're going to look at the converse of all the different properties of the parallelogram that we saw in section 2. So in the last section, section 6.2, I gave you information, told you it was a parallelogram, and asked you to find a missing side or a missing angle or something that wasn't there. In this section, we're going to have all the information given to us, and we're going to have to look at the information and say, yes, this information does give me enough information to say that the figure is a parallelogram, or no, there's not enough information. Okay, so it's a little bit different, but a lot of the same properties from the last section are going to follow through into this section. Alright, so notice when you look at all these, we have some of the ones from section 2, simply the converse of each of those. Okay, so notice we have here for 6.9, if both pairs of opposite sides are congruent, then you have a parallelogram. Okay, 6.10, you have if the opposite angles are congruent, then you have a parallelogram. 6.11, if the diagonals bisect each other, then it's a parallelogram. We already saw these in the last section, so those should be really familiar to you. This one down here, 6.12, is a little bit new. Okay, this is one stipulation that if you notice this happens in a particular diagram, you can go ahead and tell me that you do have a parallelogram. So it says if one pair of opposite sides of a quadrilateral is parallel and congruent, then you have a parallelogram. So if you look at the picture, you have this one pair of sides, AB and DC. Both of those are parallel. Notice you have the two little arrows right there, and they're also congruent. You have the little marks to prove that. Okay, we didn't really need to know anything about AD and BC. As long as you have that one pair of sides that's parallel and congruent, you can tell me that yes, you do have a parallelogram. So let's look at a few practice problems. Determine whether the quadrilateral is a parallelogram and justify your answer. So again, all we're doing here is we're looking at the properties, something about the sides. Okay, we don't know anything about the angle, so we're not even going to entertain any of those properties, but we are going to look at these sides relationships. So we've got a 35, a 35, a 20, and a 20. Since the opposite sides are congruent, we can say with confidence, yes, this is a parallelogram. Alright, pause the video for just a second. Okay, and then I'm going to go over the answer once you've decided. Alright, so which method would prove that this is a parallelogram? Well, notice you have one pair of opposite sides that are parallel. They're also congruent because they both measure 15 each. So, take a look at your choices. Where's the one that says you have one pair of parallels and one pair and that same pair is congruent? Down here, this last one. Okay, we don't know anything about the angles, so it can't be the third one. We don't know both pairs are congruent. Okay, we only know one pair. Then both pairs are parallel. We don't know that this pair is parallel. So the only one that makes sense is going to be this last one. Alright, here's another type of question. Find the values of x and y so that the quadrilateral is a parallelogram. Well, remember, to be a parallelogram, opposite sides have to be the same. So all we're going to do is set these guys equal. Okay, so AB and DC need to be set equal. AD and BC need to be set equal. Okay, so here we go. To do that, here's your first one. To solve for x, you're going to need to distribute first. And then for y, we're going to do the same thing. Okay, make sure you distribute your 3 and then solve for y. Okay, take a minute, pause your video, see what you can find for m. Alright, so this is that example where we have one pair of opposite sides that's parallel. We also want that pair of sides to be congruent, so you need to set these measures equal. So we're going to have 4m plus 2 is equal to 3m plus 8, and you're going to subtract. Okay, the 3m from the 4m is going to just give you m, and then 8 minus 2 is 6, and you are done. Alright, so here's kind of a synopsis of what we've seen here. In order to prove that a quadrilateral is a parallelogram, you just need to find one of these that's true. Okay, you don't have to show every single one of them's true. That would be way too much work. All you have to do is prove that one of these is happening, and you can tell me that you do have a parallelogram. So keep that in mind because in the next slide we're going to need it. Alright, so take a look at this one right here. We've already talked about coordinate geometry and having to plot coordinates. So here's another example. Okay, so we've got the Q, R, S, and T plotted already on our graph, and our job is to determine whether the quadrilateral is a parallelogram, and we're going to use the slope formula to do that. So just as a reminder, what is slope? Rise over run. Okay, so also one thing that you need to remember is that when we have sides that have the same slope, that means that the lines are parallel. Okay, so if QT and RS have the same slope, that means that those two lines are parallel. If QR and TS have the exact same slope, then they are also going to be parallel. So that's what we're going to be checking for. We're going to rise and run. Rise and run. Okay, so notice for the slope, remember slope's an M. Okay, slope of QT is going to be 4 over 1 because I'm rising 4 and I'm running 1. The slope of RS, which is across from it or opposite from QT, is also 4 over 1. Up 4, right 1. Very simple. The slope of QR, go down 2 and to the right 4. Remember when you go down it's negative. That does simplify to negative 1/2. And then the slope of TS is the same thing. Down 2 to the right 4. So because the two that are across from each other, QT and RS, have the same slope, and the other two that are across from each other, QR and TS, have the same slope, we can say yes, this is a parallelogram because the opposite sides are parallel. Lastly, we want to pause the video. Okay, I want you to try this one on your own, and you can either use the slope method or another method. Okay, so what are some of the other methods that you can use to determine this? You can use slope, distance formula, or midpoint formula. So again, pause the video and see if you can do this one on your own, and then we'll go over it together. Alright, so I've drawn a graph for you already. Okay, here's what your quadrilateral looks like. Okay, and so what I decided to do, since we already had a slope problem where we attempted to work the problem using slope, I decided on this one I was going to use midpoint so you could see a different method of how to prove that you do have a parallelogram or you do not have a parallelogram. Okay, so if I'm going to use midpoint, I'm going to be really talking about the diagonals. So I'm going to be concerned about EG and FH. Now remember what we discussed. Okay, if this thing is a parallelogram, then the diagonals are going to bisect each other. That means they're going to intersect in the exact same spot. Okay, so I'm going to check and see if EG has the same midpoint as FH. Okay, so to do that, I need my midpoint formula. Remember, you add your x's and divide by 2, add your y's and divide by 2. So the midpoint of EG is -1/2, comma, -3 over 2. And I need to fix that. Okay, the midpoint of HF is -1/2, -1. Now the x's, they're at the same spot, but the y's are not. So again, if you'll notice that the midpoints are different, so that means this thing is not a parallelogram. They have to intersect in the same spot for this to be a parallelogram, and because they don't, we have to say no. Okay? So that's it. This is a very short section. So if you have any questions, let me know. We're going to do a quick entry slip, so hang tight for that. Alright guys, here's your entry slip. What I want you to do is I want you to graph this parallelogram, or excuse me, this quadrilateral, and you're going to tell me if it's a parallelogram using the midpoint formula. So go back through the previous problem that we just worked together. Okay, use that as a guide, and I'll check this tomorrow when I come around for your homework check. Okay, have a good night. See you guys tomorrow.